Good morning. We're going to go ahead and get started on 2.1, and I am going to pull that up right now. All right, so for 2.1, there are 6 objectives, and it's all about equations of lines. So in 1.4, we did briefly talk about what a linear function is, and we talked about it being a line. We talked about slope man and the different ways that you can see a line occur. And so let's just refresh that again. So remember, you can have a positive slope, which is going up to the right, or down to the left would be considered a negative slope. If the line is vertical, then we call this undefined slope. And if the line is flat, then it has no slope, so zero slope. And if you're thinking about slope in terms of real world things, then obviously the first thing that's going to come up to mind may be a ramp. So or takeoff of an airplane. So if an airplane is taking off, that's a good thing. Hello, positivity, that's a positive slope. Now, when the airplane is coming back home, you're like, oh, I'm sad. I'm kind of going to miss my trip. That's a negative slope, right? And then if the airplane is just on the tarmac and it's just sliding on the ground, there's no slope. There's no change in direction in terms of an up or down motion. It's just going flat. You really don't have any feelings about that. It's like, whatever. Either you're about to take off or you just landed. It's just whatever, emotional. It's like really no emotion. So that's that zero slope piece that I think about. But if that airplane ever begins to take a deep dive downward, that is undefined. That is not something we ever want to even think about and consider. So that's called an undefined slope. That's not a function. For something to be straight, going straight down, and there not to be any motion left or right, but just a straight nosedive would not be okay. So we're going to talk a lot about slope. How do you find the equation of a line using the slope and the points that you know? So this information is going to be really important. It's vital for your final exam as well as for your next test. So let's talk about this and get into it. We have 2 different forms to choose from when we are asked to write the equation of lines. First, slope intercept. Notice that there are 2 parts, slope and intercept. That's what we talked about in 1.4, mx plus b. M is the slope. It's also how you move. It's the thing that's married to the x, okay? And then the b is the y-intercept. This is where it crosses the y-axis. So when you have your x-y-axis, wherever that line crosses the y-axis, that is your b, okay? How it's moving, like the rate at which it's changing these steps, the rise over run is how it moves. That's your slope, okay? Well, that's one form that the line can be in, but the equation, I'm sorry. The other way, we could write it in point slope form. And this one looks a lot complicated, but it's actually pretty darn simple. All you have to do is have a point, x, y, and the slope, m. You substitute those into the equation, and that is all. Okay, so we're going to talk more about that in a minute, but in point slope, we just need any point on this line. So it could be this point. And then we need the slope. So we choose 2 points and figure out how to get from there to there. Point, x, y, slope. Changing y over changing x. Okay, let's do it. All right. So equations of a line, complete the following. Find the point slope form of a line with slope of 4 passing through the point 2, 5. So the point slope form of a line is given to us. Well, first off, let's identify the point. Yes, the point is 2, 5. So x is 2, y is 5. So now the equation itself is y equals m parentheses x minus x1 parentheses plus y1. So it's going to be where you're going to substitute your m, your x, and your y. This y and this x are a part of the equation. They are there to allow us to have input values for other points, okay? So let's do that. So we put 4 in for the m because they told us the slope was 4. We put 2 in for the x and 5 in for the y. And that is because the question gave it to us. And that is all. You could stop right there and be done with your point slope form of that line. Okay. We're going to do again with a new point. In this case, the x is now 0, the y is -3. So before I show you the answer, stop and pause the video and tell me what you think the equation would be when you substitute in your values. Pause the video. Now, after you substitute these values in, we have 4 is m. This x is a part of the equation. This y is a part of the equation. The minus is actually a part of the equation as well. So for x1, we just put in 0. And for y1, we put in -3. Now we should clean this up a little bit because x minus 0, like, isn't that just x? So it's just 4 times x, not 4 times x minus something. And then the plus minus 3, plus minus means just minus. So we can actually write this like that. But of course, the textbook will allow you to leave it in that form and just be done. Like, I'm sorry, let me go back. Leave it in this form and you don't have to simplify. I simplified because, I mean, you know, why not? So you can totally simplify this or you don't have to, okay? Moving on, we have this the same graph, same points. And we need to notice that if you use different points, the point slope form of the same line will look different. So in part A, we got this. And in part B, we got this. So those really look different. They look like 2 totally different lines. However, this is the same line, so they can't be different. So once we actually simplify, we'll see that they actually are the same line. And these numbers will simplify to the exact same things. Watch out and let's do this math so you can see that these are really the same line. It don't matter which point you choose on this line. Once you do it correctly, it will always be the same line. All right, let's simplify and make it shake, all right? Uh-oh, all right. The first one, what we wanna do is we wanna distribute this 4 to the x and to the -2. That's called the distributive property. When you have the parentheses and there's some things on the inside of the parentheses, the number that's being multiplied on the out has to be multiplied by everything on the inside. So we're gonna do 4 times x, which is 4x, 4 times -2, which is -8, okay? Now we can simplify. There are no more parentheses in this thing. So now we can put these 2 together. -8 plus 5 is -3. Okay, so when we simplify this, we get y equals 4x minus 3. Now let's take the one from part B and simplify it. Again, you can distribute. You're going to get 4x minus 0 plus a -3. Simplifying that further gives you 4x minus 3. Notice that these are the exact same. They should be because they're the same line. So it's just a simplification of values, multiplication, addition, subtraction, all of that combined in like term stuff, so that you can see that the equation is actually the same. And the type of equation that we're dealing with now is truly not point slope, but it's slope intercept. So if I were to ask you, what is the intercept, the y-intercept of this line, you know that it's -3 because this is in the form of y equals mx plus b now. So your m is 4 and your b in this case is -3. Okay. One of the biggest things that I continue to see year after year for the last, how many years have I been teaching? 12 years, is when I ask for the slope, people always tell me 4x. that X is the domain. That X is the independent variable. That X is the input. That X is not a part of the slope. The slope is the number in front of the X, okay? So yeah, we got slope-intercept form of the line. Once we simplify point slope, boom, boom, easy peasy. All right, so now it says find point slope of form of a line using this first point given and then convert it into slope-intercept form. The problem, if we're using if we're using point slope form, we need to have a point and a slope, but all we got was 2 points. So what we have to do is find the slope. So step 1 is going to be to find the slope, okay? How do you do that? Remember, the formula for slope is the change in Y over the change in X. So the questions in these math questions will actually tell you what you need if you just read it. So it says find point slope form. How can you do that if you don't have a slope? The first step is to find the slope. So let's do that. Okay. Using this formula, you take Y2 and you subtract Y1. And then for the run, you take X2 and subtract X1. So let's do that. 3 minus -5 makes 8. -2 minus 1 makes -3. So we got 8 over -3, or -8/3 as our slope. Boom, love it. Now we have a point and we have a slope. This thing tells us to use the first point given, but you could use either one. It don't really matter. But it says use the first point given. And now we have our slope. So all we at this point doing is substituting. We're playing basketball, okay? So we got Y. We have our slope. We have our slope as -8/3. Our X is as 1. That came from here. The Y1 as -5, and that came from here. Notice that we didn't even bother with putting the plus minus because we know plus minus is also just minus, okay? So they jumped the gun, jumped the step. And that's that. That's point slope form right there. But it says then convert this equation to slope-intercept form. So we have our slope. By doing some manipulation, we'll end up with the equation of slope-intercept form. That's point slope. All right, so now we're gonna distribute this -8/3 together. -8/3 times X is -8/3 X. Negative times a negative makes a +8/3 here, -5, okay? Then we have to put these two together. How many of you hate fractions? Exactly. So what we're gonna do is we're gonna walk you through how this process works. So this is the answer. However, some of y'all might be thinking, man, how do you get from this to that? Okay. How did you get from this to that? The first thing you want to do is remember that with fractions, you have to have a common denominator in order to do anything. So this 8/3 minus 5 over 1, we need to write that 5 as a fraction. Any whole number can be written as a fraction, and we got to know that. Okay. Then this bottom needs to be a 3. So we're going to multiply it by 3. But whatever you do to the bottom, you need to do to the top because you don't want to really change the fraction. Lord, I'm getting sick. Okay. So that's 15 over 3. Notice that 5 over 1, 5 divided by 1 is still 5. 15 divided by 3 is still 5. So we haven't changed the 5. Okay. We're just scaling it so that we can actually combine. In essence, we're dividing pizzas so that we can look at them together. Okay. And then you just do the math. 8 minus 15 is -7. And the denominator is common, so we keep it. And that's how we get that -7 over 3. Now, you may need practice with this. This is where that skills review comes in. Do the skills review. That's a part of your NCBM grade. But do the skills review so that you can actually have practice on working with fractions, working with distributive property, things like that. Okay. And we're done with that problem. Oh, if you want to put it in function form, you just change the y to f of x. They mean the same thing, output, okay? Just the name of the function. Use the graph to find the slope-intercept form of this line. Boom, boom, we got a line. We have 2 points. So we can find the slope first. Number one, find the slope. Then you can find a point slope formula. And then step 3, simplify to slope intercept. Okay, so those are the steps. So let's do it. First step, use those 2 points and find the slope because it's not given. You could do it using the equation, or you could do it using our understanding of rise over run. So in this case, we are falling 2 and we went over 3. So our slope is negative 2/3. Changing y over changing x. Okay. The y-intercept isn't really on the graph, so it's hard to just grab it. So what we want to do is actually go forward with point slope form. Okay. So for m, we're going to put in what we know is negative 2/3. First, for our point, we can use either of these points, negative 1, 1, or 2, -1. Either one will work totally fine. So you choose whichever one you want. I'm going to choose negative 1, 1. Matter of fact, I want you to choose this one to work on and see if you get the same result in the end. Okay. So we put in negative 1. Remember, negative is already a part of this problem, so you can't take that away. This becomes plus 1. You distribute and you get negative 2/3 x minus 2/3 because negative 2/3 times positive 1. And then you have plus 1. To simplify this, negative 2/3 plus 1 over 1 equals what? Well, that 1 over 1 has to be having the same denominator. So we multiply the top and the bottom by 3. Negative 2/3 plus 3 over 3. And that becomes 1/3. So that is going to be our y-intercept. You got to be able to do that fraction manipulation off to the side. Pause that, rewind it, see if you have any questions. We'll talk about it in class. All right, next question. Find the slope-intercept form of a line satisfying the conditions. Again, a slope passing through the point. Oh my God, I love when this happens. If the point that they give us is actually the y-intercept, then we can just jump straight to the equation. But you have to be able to identify, oh, that's the y-intercept. The y-intercept always has 0 for x, okay? And then for y, it has some number. So I already know my equation is going to be y equals 4x minus 7. But to take you on the same trajectory that we've been doing and not to confuse you, let's go through the point slope form and then simplify the slope intercept. Okay, so that's what the textbook says. Hey, you can just kind of jump, but I'm actually not, I'm actually not going to jump. I'm going to say, hey, let's use the same formula. Okay, 4 times x minus 0 minus 7. So then when I substitute all of this in, I just get 4x minus 0 plus 7. Minus 0 minus 7, it doesn't really do anything. So we just got 4x minus 7. So again, you can use point slope. We'll do the same here. We put the slope in, -2. And we simplify in distributive property. So this is negative 3x minus 6 plus 1. So we have negative 3x minus 5 when you put those two together. Okay. This is kind of fun. I mean, maybe you're not having fun. I'm sorry. I just get so excited about doing math. But that's that. And that's how you do it, okay? Got to excuse all this work that I'm about to cover up, but that's that. All right. Find the slope-intercept form of a line satisfying the conditions. Parallel to negative 1/4 x plus 5, passing through the point -1, -6. All right, so we have some new knowledge here. And it says something parallel. Parallel lines look like a railroad track. This means that they have the same slope. So if it's going to be parallel to this line, first identify the slope in this line. The slope is -1/4. Our new line that we're doing is also going to have that same slope. That's all parallel means. It's going to just tell you, hey, these lines will look like railroad tracks. And they're going to have the same slope. Then it gives us a point to pass through, x1, y1. So we're going to use our slope, our point slope formula. Okay. Y equals -1/4 times x minus -1 minus 6. Remember, it's plus, but it's already a -6, so we know that's going to turn into -6. Okay. I'll clean this up a little bit before I simplify. That's plus, and that ends up being a subtraction. Okay. Now I'm going to distribute. And then we finally simplify. Some of you hate this part, but I hope I'm making this make sense for you. So the first thing you have to do is write this as a fraction, then multiply by the same denominator on top and bottom. -1/4 minus 24/4. Notice that 24 divided by 4 is 6, so we ain't done nothing wrong. And we simplify. -1 minus 24 is -25/4. So we get y equals -1/4 x minus 25/4. 25/4 is a decimal, so we just leave it like that. You could change it to decimal if you want to. Okay? And that is it. That is all. Love, life is good. Okay. So what we're going to do now is I'm going to erase all this so we can see how the textbook says that we should do it, confirming what we said was correct. Okay. So you can pause the video. You don't have to watch me erase. All right. It says parallel to, that means the same slope. Yeah. All the parallel lines are just having the same slope. They have the same rate of change. Okay. So we're using the slope of -1/4. Using point slope formula, we plug that in, we simplify, and boom, we got what we got. Yay, I'm excited. That was cool. Got it right. Confirmation, and we did the same way the textbook would have done it. Now, this one says perpendicular. Perpendicular is a bit different. It doesn't mean same slope. Instead, it actually means that it crosses. It has to cross the line. So it went from a negative slope, which we had, to now being a positive slope because it has to go the opposite direction if it's perpendicular. So in fact, they're negative reciprocals. So that means if our slope in this line, -1/2, we're going to make it positive. So it's going to be positive, and then we're going to flip it. So instead of 1/2, we're going to have 2/1. Okay, so our slope is just 2. So when it's perpendicular, you have negative reciprocals. Change the sign. and flip the fraction. Okay. Then we use point slope formula and we move about our business. We put the 2 in for M. For X, we're gonna put in 1. For Y, we're gonna put in a 5 because we got that from the point they told us to use. And we simplify. 2x minus 2 plus 5 minus 2 plus 5 is positive 3. So we get y equals 2x plus 3. Life is good. Okay, let's recap that problem. Sorry, before we go on to this example 6. Recapping this problem, they're very similar to the perpendicular problem that we just did. I mean, the parallel problem we just did. The difference is that parallel, you might want to write this down, means same slope. Perpendicular means negative reciprocal slope. So you have to change the sign and flip the fraction if you're dealing with perpendicular. But the rest of the steps are the exact same. Complete the following. Is the line a horizontal line? Looks pretty horizontal to me in the horizon, yes. It's a horizontal line and it's represented by a function because it passes the vertical line test. Okay. What is the slope? Well, oh, I'm so sorry. Well, the slope, positive, negative, undefined and no slope. So the slope man tells us the slope of this horizontal line is 0. Label a point on the graph. So let's just label 1. Here we go. 0, 2. Another one is 4, 2. -2, 2, -4, 2. What do they all have in common? Well, they all have 2's. So what do you think is going to be constant in our equation? Y equals 2. Y is always 2. So the equation of our line is just that. It's just y equal 2. That's it. No matter what we have for x, y is always 2. So that's the equation of the horizontal line. I will tell you this, horizontal lines always have y equals a number. And that number is defined by where it is on the y-axis. That's it, that's all. Okay, now we're gonna look at a vertical line. Is this vertical line a function? Well, if we draw a vertical line on it, then no, it's not a function. You know why? Because it fails the vertical line test. So no, this is not a function. All of our x values have like different y values, okay? So the slope of this line, go back to slope man, undefined. This is an undefined slope because you can never divide by 0. That's why it's undefined. Label points on the graph, let's do that. Now, what do they all have in common? 3, 3, 3, 3, 3. X is always 3. So what do you think this equation is? X equals 3. And I will tell you that a vertical line always is going to be of the form X equals a number. Because it doesn't matter what the Y is. X is always going to be that number based on where it crosses the x-axis. That is all. All right, what do you know about the x value of the y-intercept? Let's look. This is the y-intercept because this is the y-axis and this is where it crosses. And this point is 0, 3. The y-intercept is always going to have a 0 as the x value because it has to cross this line. And what is x in this line? 0. It's always, x is always 0. Y is the value. So for the y-intercept, x is going to be always 0. okay? It says, what do you know about the x-intercept? Well, this point is -2, 0. Well, the y value is always 0. Okay, so the y value in this case is 0. So if you plug in 0 into your equation and you work it backwards to solve for x, you'll see you'll be able to solve for x and get x equals -2. But if you have the graph, you could just visualize it. Oh, that's -2. Right here, oh, the y-intercept is at 3. Just count on the graph. You don't have to do all the math to figure that out. Okay. All right, we are getting to the nitty-gritty part where we actually are writing formulas and using applications. So in 1998, Toyota sold 1.4 million vehicles. And in 2007, it sold 2.3 million vehicles. Baby, Toyota is growing, okay? It says find the slope of the line. So first off, finding slope, you have to have 2 points. So let's identify those 2 points. We can organize those points in a table if we wanted to. So we have 1998, 1.4 million, 2007, 2.3 million. So the change in Y, the change in how much money they were making is 0.9. And the change in years, that's 9 years that passed. So 9/10 of a million over 9 years means that there was a change in 1/10 every year. Increased by 1/10 of a million. That is 100,000 vehicles each year. All right, let's take it a step further. Now we know our slope. Find the function of the formula for the function that models the sales data. So we have a slope and we have some points. So we can use point slope formula. Point slope formula says, hey, M we know is 0.1. And let's use the 1998 and the 1.4. 1998 goes in for X, Y is 1.4, and we see our M. That's the formula. You can stop right there. If you wanted to continue, you can get it into slope intercept form by actually multiplying distributive property and then simplifying. And that would be considered slope intercept form. Okay. Find a formula for a function that models the sales data. Let X represent the number of years after 1998. So we're going to do the same thing, but instead of X just representing years, we're going to say that X represents the number of years after 1998. Now, this part is confusing for a lot of people, but if we're talking about 1998 being the starting era, we're going to look at 1998 as if it is 0. Okay, so we're going to say 1998 was 0, the beginning. So then 2007 would be 9 years later. Okay, so the 1 would be 1999, 2 would be 2000, 3 would be 2001, and so forth and so on. Okay. So now we can just use our slope intercept form because we have X equals 0. So we know the Y intercept is 1.4. That's where it is at the very beginning. Okay, so B is 1.4. How do we know that again? That is our Y intercept. That is the beginning of time. 1998 is the beginning. We know it's 1.4. So our beginning is 1.4. Okay, and we know that because we know that the Y intercept always has X as 0. And then we just have our slope. And so, baby, we done. We don't have to do no more math. That's that. Okay? All right. Our last concept, I think maybe second to last concept, is intrapolation and extrapolation. These words sound so large and so confusing, but they're super simple. Intrapolation, extrapolation. This is inside of the data. This is outside of the data. So if we're going to be estimating sales for 2004, if we have 1998 to 2007 data, and we want to find 2004, is 2004 inside of this range or outside of this range? Well, 2004 would be in the middle of this range, so that's called intrapolation. Okay, so it's actually about to, so this is called intrapolation because 2004 is between the years that we're given. And so basically what we're gonna wanna do is we're gonna actually say, well, if we have 1999, well, if you wanna do it from the first part, you could just substitute in 2004 into this equation because X was just the year. So if we do that, we get 2 million cars were sold. However, if we use the other formula, remember 2004, the X is not representing the year, it's the number of years post 1998. So 1998 was 0, 99 was 1, 2000 was 2, 2001 was 3, 02 was 4, 03 was 5, and 04 was 6. So you plug in a 6 to represent 2004. So we just plug in a 6 right here. And of course we get out the same 2. So it doesn't really matter which equation you use. You just have to know what that X represented. So again, for the first formula, X represents the year. The second formula, X represents the years post 1998. So it's actually just simplified numbers. And it's intrapolation because the year that we're looking for is inside of our data. Whereas this one, it says find 2014. Okay, so 2014 is outside of our data, which means that we're going to be using extrapolation. Okay, so in the first formula, we can just plug in the year 2014. In the second formula, we'd actually have to plug in the number of years post 1998. So to find it easily, you just subtract 2014 minus 1998, and I think it's 16. So you plug a 16 in. Okay, so part one, plug in 2014, and it says 3 million cars would have been sold in 2014. That's a guess, it's an estimate because again, we only had data from 98 and 2007, but we're using a pattern to find out. Part D, we would say, oh, well, how many years is it since 2014? That looks like about 16 years. So we plug 16 in for X, and we get out 3 again. 3 million cars were sold, okay? But we use extrapolation because again, 2014 is on the outside of our data range that we actually have. Okay. The graph shows a runner's, I can't even read anymore. The graph shows a runner's distance from the finish line of a 100-meter race over several seconds. Evaluate F of 10 and interpret your results. So F of 10, this looks like it's going by 10. So 10, 20, 30, 40, 50 seconds. So 10 seconds to me looks like 50 meters in distance. So yeah, F of 10, that point is 1050. So yeah, F of 10 equals 50. It says find the slope and interpret what the slope means in the context of this problem. So we found another point on the line, 20 and 0. So 20 seconds, they were back at 0 meters. So the change in Y is down 50 and over 10. So I'd say it's -5 as the slope. Change in Y is down 50, change in X is 10. So the runner's distance decreased by 5 meters per second. So this is how fast they're running towards a finish line. It took them 20 seconds. Oh, I'm so sorry. It took them 20 seconds to run 100 meters. All right, last questions. Same situation. This person is running towards the finish line. of a 100-meter race over several seconds. In fact, 20 seconds. That, to me, that seemed like a whole lot. Anyway, find the x-intercept and interpret it. X-intercept is right here. The point is 20, 0. This means it took 20 seconds for them to get to the finish line. Find the y-intercept. This is 0, 100. That means at 0 seconds, this person was 100 meters away from the finish line. Okay. Find the slope-intercept form of this line. So we know our slope is -5. We know our y-intercept, we know our y-intercept is 100. So we put that together, we get -5x plus 100. Our y-intercept, again, is just right here. Our slope, we found it to be 5. -5. Whoop, whoop, we done. That is 2.1. Yay, you made it. If you don't remember anything or you don't understand something, stop, pause, rewind, watch it again. If it still doesn't work, start asterisk, make a note so when you come to class, we can talk about it.